Hi everyone. Notes 2.8, which are on adding and subtracting rational expressions day 2, is your last set of notes for the unit. And there is no extra paper for this, so you're just going to want to take notes on your own paper. This picture right here, don't worry about it, don't get this down. This picture is just going to kind of give you a heads up as to what it is to expect for this, because if you notice, things can get kind of complicated. This is the toughest lesson of the whole unit. Okay, so the first thing we're going to do is we need to figure out how to find common denominators. So the first thing we need to do when we find common denominators is we're going to factor each denominator if possible. Okay, and then we're going to include each factor in our LCD. Because the factors, when you multiply them together, end up being our multiples, which is what we're looking for. Okay? Example number 1. Take a moment to get the example written down, and then we will go ahead and do what we said we need to do. So the first thing I want to do is factor my denominators. So if you notice right here in my first denominator, it's y squared plus 5y plus 4. So when I factor that, I end up getting y plus 4 and y plus 1, because 4 times 1 is 4 and 4 plus 1 is 5. Okay? So at my first denominator, I have y plus 4 times y plus 1. And in my second denominator, it's already factored. It's 5 times y plus 1. So I have 3 different factors right here in my denominator. I have a y plus 4, I also have a y plus 1, and then I also have a 5. So that means that my LCD is going to be a mix of all of those things. Now, I also have this y plus 1, but it's already included right here with this y plus 1, so I don't need to include it twice. Those guys end up going together. So that means that my LCD is going to have to be 5 on the outside, because that's my greatest common factor, with a y plus 4, because we have y plus 4 here, and then we also have y plus 1. Okay? So now that I figured that out, I'm going to rewrite my fractions so I don't get confused with my common denominators. So that means that my new fractions, my newly written fractions are going to be 1 over y plus 4 times y plus 1, okay, minus 3 over 5 times y plus 1. Now my goal is to get this common denominator here. So I'm going to write my common denominator, 5 times y plus 4 times y plus 1, okay? And then I'm going to look at my first fraction, and I'm going to see, well, I have a y plus 4 already, and I have a y plus 1 already, but I'm missing that 5. So I need to multiply by 5 over 5. So 5 times 1 is just 5. Okay, and then looking at my second fraction right here, I have the 5, I have the y plus 1, but what I'm missing is y plus 4. So I'm going to need to multiply by, in brackets, y plus 4. Okay, so I've got a 5 here, minus 3, and then brackets, y plus 4. Then I'm going to simplify my numerator, so I'm going to distribute that negative 3 through. So I get 5 minus 3y minus 12 all over 5, and then y plus 4, y plus 1. Okay, so then when I put together my like terms, I've got 5 and negative 12, which is negative 7, and then I just copy down the negative 3y. And then I've got 5 times y plus 4 times y plus 1. And this is my final answer, because I can't factor this numerator any further. Okay? All right. Last thing I'm going to do is find my restrictions on my variables. So for my restrictions for my fractions that I have here, I can't have 0 in my denominator. So I set each denominator equal to 0. So my first denominator is y plus 4 times y plus 1. When I set it equal to 0, that means that y plus 4 equals 0 and y plus 1 equals 0. So that means that here y would equal negative 4, and here y would equal negative 1. These are the values that would give me 0 in my denominator up here, but I'm not allowed to have 0 in my denominator, so y is not allowed to be negative 4 or negative 1. Now I'm going to take my second fraction, which is 5 times y plus 1, and set that equal to 0. So I set each part equal to 0. I set 5 equal to 0, but that's not true. So I just totally ignore the fact that I have a 5 there. I don't need it there because 5 will never equal 0. Then I set y plus 1 equal to 0, so I get y equals -1. Well, we already have that here, so that means that my restrictions on my variables are that y can be any variable that we want, or sorry, any value that we want, except for this -4 and this -1. Because again, if I plug that into my denominators, I'll end up getting 0. Okay. Example number 2 down, it's 7 over x plus 6 over x plus 5. So the first thing I'm going to do is factor my denominators. But if I just have an x here, I can't factor it any further. And looking at this x plus 5, that's not factorable any further either because there's no GCF, it's not a difference of perfect squares, it's not a trinomial, and it can't be factored by grouping. Okay, so now that I've done that, the next thing I'm going to do is find my LCD. And for my LCD, I need to include every single factor. Well, we have a factor of x right here, and then we also have a factor of x plus 5 over here. And I can't change an x into an x plus 5 by multiplying, only by adding 5, but we can't do that when we have fractions. We only multiply to get common denominators. So I have to actually put these guys together. I put my first factor and my second factor, and I include them and multiply them together. So my LCD would be x times x plus 5. Okay, so I'm going to rewrite my expressions, my fractions, and I'm going to get a common denominator of x times x plus 5. Well, my first fraction has an x, but it's missing an x plus 5, so I need to multiply this by x plus 5. And whatever I do to the denominator, I also have to do to the numerator. Okay, so this ends up being 7 times in brackets x plus 5. Okay, and then over here, I already have the x plus 5 that I need for my common denominator, but I'm missing the x. So I'm going to multiply by x. But whatever I do to the denominator, I also have to do to the numerator. So I end up getting plus 6x. Now, when I distribute the 7, I get 7x plus 35, and then I get plus 6x. And that's all over x times x plus 5. Then, when I collect my like terms, I end up getting 13x plus 35, because 7x plus 6x is 13x, all over x times x plus 5. Now, my denominator is factored, so I don't need to simplify that any further. But in my numerator, I'm going to go through my list of questions. First question is there a GCF? And there isn't. And then it's none of the other type of factoring problems, just looking at it. So therefore, this is as factored as possible, so nothing can cancel out. So this is my final answer. Okay, now for my restrictions, I'm going to look at the original problem, and I'm going to set each denominator equal to 0. So I'm going to say x equals 0, and it's already solved. And I'll also say x plus 5 equals 0. Well, when I solve for x, I get x equals -5. So that means that my restrictions are that x can't be 0 or -5 because I get 0 in my denominators here, but x can be anything else. Example number 3 is 2 over x squared minus 4 minus 1 over x squared plus 2x. So I'm going to go ahead and keep the 2 in my numerator, but in my denominator, I see that this is a difference of perfect squares. So I can factor this as x plus 2 times x minus 2. Okay, and then I'm going to copy down the -1 over. Now looking in my denominator here, I see that there's an x in common, so I can factor out a GCF of x. So I get x bracket x plus 2. Okay, so based on that, to find my LCD, I have an x plus 2 here, and I also have an x plus 2 here. So that's in common with both of my fractions. So I know for a fact that x plus 2 is going to be part of my LCD. I also have an x minus 2, which is different than x plus 2, so I need to include that. And I also have an x. So therefore, my LCD is going to have to be x times x plus 2 times x minus 2. Okay, because I got these values right here from my denominators here. So here's my x plus 2 that's in common, here's my x, and then here's the x minus 2. Okay? All right, so now we need to change all of our fractions so that they have that common denominator of x times x plus 2 times x minus 2. So looking at my first fraction right here, I have the x plus 2 I need, and I have the x minus 2 I need, but I don't have this x. So I need to multiply by x over x. So x times 2 ends up giving me 2x right here. That's how I get this 2x right here, okay? Now, looking at my second fraction, I have the x in my denominator, I have the x plus 2 in my denominator, but I don't have the x minus 2. So I'm going to multiply by x minus 2 to get the denominator that I need. So this becomes minus 1, and then in bracket, x minus 2. Okay, now I need to distribute the negative 1 through. So I end up getting 2x, and then negative 1 times x is negative x, and negative 1 times negative 2 is positive 2. All over x times x plus 2 times x minus 2. Okay, so then 2x minus x is x, so I get x plus 2 over x times x plus 2 times x minus 2. Well, I have an x plus 2 term here and an x plus 2 term here, so I can cancel all of that stuff out. So I end up getting 1 over x times x minus 2. And that's my final answer. Okay, now for my restrictions, I'm going to look at my original fractions. So my original fractions are right here, and this is telling me that x cannot be, right here, this means x cannot be negative 2, because if I were to solve the equation x plus 2 equals 0, I would get x equals negative 2. This is telling me that x cannot be positive 2, and then this blue piece right here is telling me that x cannot be 0. Okay, hopefully the restrictions are starting to make a little bit more sense to you guys. Last question that we're going to do is this example right here, so go ahead and write it down. And then we're going to rewrite our fractions with our factored denominators. So I'm going to keep the 7 in my numerator, and then I look at my denominator, and the first question I ask myself is there a GCF? And there is. I can divide 10 and 6 both by 2, and they're also both divisible by x. So when I factor out a 2x from a 10x squared, I get 5x. And when I factor it out from 6x, I get plus 3. Okay, then I'm going to copy down the minus 8 over, and then in my second fraction right here, in my denominator that I have here, it's a trinomial, so I'm going to try to factor it as a trinomial. Remember, it's not always possible, but I'm going to try to see if it's possible here. So I know that my first two terms should multiply together right here to give me 5x squared. So what I probably want to use is 5x and x, because 5 and 1 are the only factors of 5. And then here, these last two terms need to multiply together to give me negative 6. So I will try 3 and 2, and I'll try a 3 here and a 2 here and see what ends up happening. If that doesn't work, I'll switch them. If that doesn't work, I'll try 6 and 1. So this right here gives me the 3x, and this here gives me a 10x. And when I put 3x and 10x together, I'm wondering if I can get negative 7x. And I can if the 10 is negative, which means the 2 needs to be negative, and if the 3 is positive, which means the 3 here needs to be positive, okay? So now that I've done that, the next thing I need to do is identify what my LCD is going to be. So, same thing, I have a 2x here, so I know 2x is going to be part of my LCD. I also have 5x plus 3, but it's in common in both of my fractions, so I only have to write it down once. And then I also have x minus 2 right here. So that means that my LCD will be 2x times 5x plus 3 times x minus 2. And essentially, when you're finding an LCD, you just have to make sure you don't leave anybody out, okay? So now that I've done that, my new fraction is going to have a denominator of 2x times 5x plus 3 times x minus 2. Okay, so looking at my denominator, what's missing in my first fraction, I have the 2x, I have the 5x plus 3. I'm missing the x minus 2. So I'm going to multiply by x minus 2. So I end up getting 7, and then in brackets, x minus 2. Okay, and then in my second fraction, I have, in my denominator, I have the 5x plus 3, and then I have the x minus 2. What's missing is the 2x. So I need to multiply by 2x right here. So this is going to be minus 8 times 2x. Now, when I simplify my numerator, I'm going to distribute that 7, so I get 7x minus 14, and then 8 times 2x gives me minus 16x, all over 2x times 5x plus 3 times x minus 2. Okay, now I'm going to put together my like terms. 7x is like negative 16x, so that gives me negative 9x, and then I have a minus 14, all over 2x times 5x plus 3 times x minus 2. Okay, then I'm going to look at my numerator and see if I can factor that numerator. Is there a GCF? There's nothing in common right here. I mean, I guess I technically could factor out a -1, but it really doesn't help me out at all because there's nothing to cancel out with on the bottom in the denominator. Is it a difference of perfect squares? The only perfect square we have is 9. There's an -9 is actually not even a perfect square. X is not a perfect square, and 14 is not a perfect square. It's not a trinomial I can factor. I can't factor by grouping, so it's completely factored. So this is my completely simplified combined equation. Okay, last thing I need to do is find my restriction on my variables. So I can see that I have 2x as a factor, so I set that equal to 0, so that means that x equals 0, okay? Then I set my 5x plus 3 in my denominator equal to 0, because remember, each factor would give me a 0, and I don't want to get 0 in my denominator. Subtract the 3 from both sides, you get -3, which means x is -3/5. And then lastly, you're going to take x minus 2, and set that equal to 0, so x equals 2. So therefore, my restrictions are that x cannot be, right here, x cannot be 0, -3/5, or 2. Okay? Come with questions. I will see you later. Have a great day.